first one I already have kind of factored out just to make it a little bit faster. If it wasn't factored out though, you would just have to either try to factor by grouping on that bottom because there's 3 factors, so factor by grouping, or you have to use long division with the rational roots theorem, so the P over Q stuff, to factor things if you can't just factor like with quadratic or something like that. So keep that in mind. All right, so step 1 of graphing these things is identify all your parts. All right, on anything that can be canceled out of top and bottom makes a whole. All right, so here we would have a whole at x is equal to 2, right? If you want to get the point for that, then you would take the 2 and you would plug it into what's left after you get rid of the whole, right? So those are gone. So plug that in. That would give me 6 on top, 5 times -3. All right, so that would end up with 6 over -15ths. Okay, and of course when we go to graph that, you just guesstimate a little bit. I just kind of made up random numbers, so they might not work out pretty, but that's okay. So there's your whole, right? It's going to be at 2 -6/15. If they just say a whole exists at x equals whatever, then you just put the x part. All right, anything that's left over in the numerator is a x-intercept, also known as roots, also known as zeros, just depends on what they ask for. So I know I have an x-intercept at -4. Right, and then I've got in the denominator there, those are your vertical asymptotes. So I've got a vertical asymptote at x equals -3, just setting each piece equal to 0, and x equals 5. Right, so x-intercepts, wholes, vertical asymptotes, horizontal asymptotes. So in this particular case, I've got an x squared on top, and I've got x cubed on bottom. So the degree on bottom is bigger than the top, which means that it's going to have a horizontal asymptote of y equals 0. So anytime degree on top is bigger than the bottom, is smaller than the bottom, I'm sorry. So anytime the degree on top is smaller than the degree on bottom, it's automatically a horizontal asymptote at y equals 0. Again, keep in mind that you can cross horizontal asymptotes. So we have an x-intercept, so we're going to end up crossing. Right, so then the only other thing that I need after that is going to be my y-intercept, right? So our y-intercept is the same thing it always is, plug the 0 in for x, right? So that would give me 4 over 3 times -5, right? So we get some y-intercept at -4/15. All right, kind of some ugly numbers, but it's okay. All right, so then graphing them, we graph all those pieces. So y-intercept at 0, -4/15. So if this is 1, it's just somewhere in here. Okay, x-intercept at -4. Right, we had a whole at 2 -6/15, which is half-ish. Okay, you've got a vertical asymptote at -3, a vertical asymptote at 5, and the horizontal asymptote is on the x-axis. Okay, so it looks like that. So then from there, we kind of just need to know, that's a point, what exactly these things are doing near the asymptote. So for instance here, all right, so this asymptote here is at -3. We already know what it's at -4. So you can kind of pick a point in between if you want to, or you can pick a point at the bottom. So if I did -5, so go over 1, -5 would give me -1 over -2 times -10. Right, all of that together is going to give me a -1/20th. So we're really small on the bottom, so I know it's going to come this direction. So that tells me that since it has to go through this, right, that it's going to kind of come from the bottom there, and then it's going to go up through and get to that side. All right, so this is one of those that does that little weird where it just comes in from the bottom instead. Okay? Huh? It's just about right. So then In between, you can kind of already see, and we don't have an x-intercept here, so we know that it's not crossing there. We can, since it's not going to cross the x-axis and this thing goes through here, we already know this thing's going to go down there. We are going to go through that hole but not actually touch it, so it's going to look something like that. All right, again, I can't go up through the x-intercept because I don't have any x-intercepts there, so I know I'm not crossing the asymptote in the middle there. And then you just need to pick something out here. So this one's at 5, so pick 6. All right, that would be 10 over, right, that would be 9 times 1. All right, so 10 over 9, so a little bit over 1, so we're somewhere right around here-ish. All right, so that tells me that this thing's going to do this on this side.
So how do you know it, like, it confuses me how, like, one side of it goes below the x-axis and the other one doesn't.
Because it had an x-intercept, so you have to cross it.
Oh, okay.
But how did you know, like, the direction? Because you just had that one point, so couldn't it have also, like, done, like, the upside down or, like,
So it's going to approach as we go to negative infinity. We know it approaches 0 because of the behavior that the bottom is bigger than the bottom has a bigger degree than the top. So it has to approach 0 out here. So the only thing it can do is go towards 0. And since this number gave me negative, I know I was at the bottom and not the top. If I had gotten a positive number, I would have started on top, gone through the x-intercept, and gone to the bottom. And you can test a point, negative 3.5, and plug it in, and you'll get a positive number. Okay? So then, second one, right, and this might kind of help. So second one, here I've got the same degree, so I know my horizontal asymptote is a ratio of the coefficients, so negative 1 divided by 1. All right, so it's just negative 1. All right, I can kind of do them as we go. All right, so negative 1. Got a horizontal asymptote there. All right, and then the bottom, right, so we're going to factor this thing out. So on top, I can take a negative x out. That leaves me with, let me do it actually off to the side here. All right, so I can take a negative x out. Will leave me with x plus 5. On the bottom here, x plus 1, x plus 1. Right? I would look to see if anything cancels to create holes, but nothing does. Right? So there are no holes. Okay. Looking for x-intercepts. Set the top equal to 0. That's going to give you your x-intercept. So I've got 1 at 0. All right, because that's just 0. And then I have 1 at negative 5. Okay, so we can put those on there. So x is negative 5, 5, and 0. All right, y-intercept obviously is already 0 because it's going through the origin. We've already crossed the y-intercept. All right, so then from there we got to look at vertical asymptotes. I know I have a vertical asymptote at negative 1. All right, there's my vertical asymptote. Okay, there's only one because this is the same one twice. Okay, so there's your vertical asymptote. So then from there you can already really tell exactly what these things are going to do because this is going to cross here, all right, and it's got to approach 0 as we go out. So it's going to go through there, kind of do that number, and then here it's going to do the same sort of thing. Okay. You can always check. You're not going to have anything crazy on this test that you have to worry about checking to see if it goes through the asymptote. But you can check it to see if it goes through the asymptote. All right, so to check. Yeah. So you would just set it equal to negative 1 and then solve. All right, so set it equal to negative 1 and solve. You're not going to have anything on this high school test that's going to make you do that. So don't worry about doing that. It can cross it, but they're going to be noticeably, like they're going to cross at like x-intercepts or some other point.
Oh, okay.
Or when you test your value, or when you test your values, you'll see that it comes from the bottom instead of the top, like this one did. All right. So then, all right. So that's really it for that one. And then the last one, right? So the degree on top is bigger than degree on bottom, which tells us there's going to be a slant asymptote. Right. So horizontal asymptote doesn't exist. Okay. But if there's no horizontal asymptote and it doesn't, when I factor this out, the denominator doesn't cancel. All right, so since the denominator doesn't cancel, then we know there has to be a slant asymptote. All right, so there'll be a slant asymptote to divide, yeah. So to get that, you're just going to divide. All right, so we'll take our x plus 2, divide that into the x squared plus 4x plus 3. All right, so just normal. You can use synthetic if you want to do that. It doesn't really matter. All right, x squared, 2x, change both signs. All right, that's zeros. That gives me positive 2. All right, so then positive 2 would get me to that. Change both signs, you get negative 1. Remainder, we don't really care about. All that's going to do is change how quickly you get to the asymptote. It doesn't actually change what the asymptote is. So this is my slant asymptote. Okay, so when I go to graph this thing, right, I would graph the just basic line at x plus 2. So y-intercept of 2, slope of 1, right, over 1, up 1, down 1, over 1, that kind of good stuff, right? And then draw your asymptote. Okay, so that's how you get your slant asymptote. And then everything else is the same. So vertical asymptote is x is negative 2. Alright, there's your vertical asymptote at x is equal to negative 2. You've got x-intercepts, right, at negative 3, it's the top, negative 1. Again, top part of your thing, once it's factored, creates your x-intercepts, right, and negative 1. Okay, so just from that, you should be able to tell exactly where your graph is going to go there. Okay, but we'll look for a y-intercept just because.
I thought we already found a y-intercept.
Did we?
Yeah, because we used it to find the slant asymptote.
But that's the y-intercept of the slant asymptote. That's not actually even on the graph, right? The asymptotes don't actually exist on the graph. If you graph them in Desmos, you won't ever see asymptotes, right? On the TI-83s, you see the verticals, but it's only because your programming is different and it doesn't understand discontinuities. So what it does is plot a bunch of points on either side, and then when it draws the graph, it just connects the dots. That's why it looks like it draws a vertical asymptote, but it's really not. It's really just connecting the top dot to the bottom dot. Anyway, so y-intercept, you got to plug a 0 in for x. All right, so that would give me, do that over here, 3 times 1 over 2. All right, so just 3/2. All right, so right here would be my y-intercept, and then that means this thing's going to go from here, close to the asymptotes, up through the top. Okay, that's the 3 different types. So really it's just factor, see if anything cancels, that makes wholes. Whatever's left on top makes your x-intercepts. Whatever's left on bottom makes your vertical asymptotes. And then you need to know the 3 rules for your y-intercepts. Degree on bottom bigger is automatically 0.
For your y-intercept. For horizontal asymptote.
For a horizontal asymptote, sorry. Right? Degree on bottom bigger makes your automatic 0. Right? If the degrees are the same, you divide the leading coefficients. And then if the degree on top is bigger, then you have to do the long division to get the slant asymptote. And that technically means horizontal asymptote does not exist.
Okay, so if there's no horizontal asymptote, then there's
You ignore the remainder.
Yes. Unless everything on bottom happens to cancel out. That's the only other option. Like we had a few that turned into lines because the bottom just went away. And then it's just a line. Yes, it can go past slant asymptotes as well.
if you're